Section 7.8 Applications. Let's do on page 303. Oh, let's say problem number 3. Problem number 3. The numerator of a fraction is 3 less than its denominator. If 1/10 is added to the fraction, the result is 1/2. What is a fraction? Okay, so let's do this. So I guess let x equal the denominator of the fraction. So it says that the numerator of the fraction is 3 less than its denominator. If 1/10 is added to the fraction, the result is 1/2. Let me multiply both sides of my equation by the least common denominator, 10x. And so the x's cancel, and so I get 10x minus 30 plus, well, the 10's cancel, so I get x equals 10x divided by 2 is 5x. Let me combine like terms. So 10x plus x is 11x minus 30 equals 5x. Add 30 to both sides of my equation. Subtract 5x from both sides of my equation. And so I get 6x equals 30. Divide both sides of my equation by 6. And so I get x equals 5. And so the numerator, denominator is 5. But so the denominator is 5. The numerator is 3 less than the denominator. So 5 minus 3 is 2 over 5. And so my fraction was 2/5. So if you add 1/10 to 2/5, if you add 4/5 plus 4/10 plus 1/10, you get indeed 1/2. So, okay, that's correct. Let's do problem number 6. The numerator of a fraction is 3 less than the denominator. If the denominator is added to the numerator. And the numerator is subtracted from the denominator. The new fraction is 11 over 3. Find the fraction. Okay. So again, let x be the denominator. Of the fraction. If the numerator is 3 less than denominator, so the numerator is 3 less than denominator. If the denominator is added to the numerator, and the numerator is subtracted from the denominator, the new fraction is 11 over 3. Well, let's simplify this. So let's get rid of the parentheses. So I have here x minus 3 plus x over x minus x plus 3 equals 11 over 3. And so I have here 2x minus 3 over 3 is 11 over 3. And so let's multiply both sides of my equation by 3. And so I get that 2x minus 3 equals 11. Add 3 to both sides of my equation. And so I have that 2x is equal to 14. Divide both sides of my equation by 2. And so I have that x is equal to 7. And so the denominator is 7, and the numerator is 3 less than denominator. So I have 4 over 7. Okay, and so indeed, the numerator is 3 less than the denominator. And if you add the numerator and denominator, you get 11 for the numerator. If you subtract the numerator from the denominator, 7 minus 4 is 3, you get 11 over 3. Yes, okay, good. So that's a correct answer. Let me do problem number 8. The sum of a number and its reciprocal is 37 over 6. No, it's not. Is, I look at the wrong problem. Sum of a number and its reciprocal is negative 25 over 12. Find the numbers. Okay, so let x be the number. So the sum of a number and its reciprocal, 1 over x, is negative 25 over 12. Let me multiply both sides of my equation by 12x. And so I get 12x squared plus the x's cancel, plus 12 equals, the 12's cancel, negative 25x. Let me add 25x to both sides of my equation so that the right-hand side of my equation is 0. So I get 12x squared plus 25x plus 12 equals 0. So let me do this. Let me factor. And so I get 12x squared plus 16x plus 9x is 25x plus 12. Set each factor equal to 0 since the real numbers have characteristics 0. Subtract 3 from both sides of my equation. And so 4x is equal to negative 3. Divide both sides of your equation by 4. So x equals negative 3 over 4. And subtract 4 from both sides of my equation. Divide by 3. Oops. Divide by 3. And so x is equal to negative 4 over 3. So you can either take x to be negative 3 over 4 and its reciprocal negative 4 over 3, or x, your number being negative 4 over 3 and the reciprocal is negative 3 over 4. So you have two answers. One of them and the other one is your reciprocal. Let me do problem number 12. Yeah, let me do problem number 12. A steamer. Goes downstream and covers the distance between two locations in 4 hours. While it covers the same distance going upstream in 5 hours. If the speed of the stream is 2 miles per hour, find the speed of the streamer in still water. Okay, so we have some steamer. Yeah, I'll just, good enough. Okay. Um, and it can, here's a stream. I guess it's going in this, the stream is flowing in that direction. Okay. And so um, it goes downstream in 4 hours. So this way it takes 4 hours. While it covers the same distance. So say this is the quote unquote distance going upstream. Wait. It goes downstream in 4 hours and upstream in 5 hours. So there. And it goes in 5 hours. The stream is going this way. And this stream goes at 2 miles per hour. Let's say that the steamer in still water goes X miles per hour. Therefore, when it's traveling with the stream, it's going X plus 2 miles per hour. When it's going against the stream, it's going at X minus 2 miles per hour. Okay. And I have that distance is rate times time. The distances are the same. Therefore, the rate, X plus 2, times the time 4, should be the same distance as, well, when you go upstream, you go at a rate of X minus 2 miles per hour. It takes you 5 hours. So let's solve for X. So let me multiply the 4 inside the parentheses, 5 inside the parentheses. And so I have here 4x plus 8 equals 5x minus 10. Add 10 to both sides of my equation. Subtract 4x from both sides of my equation. And so I have here that 18 equals x. And so the steamer goes 18 miles per hour in still water. Okay. Let me do, say, problem number 18. A plane left 30 minutes later than the scheduled time. In order to reach its destination, 1,500 miles away on schedule, it has to increase its speed by 250 miles per hour from its usual speed. Find its usual speed. Okay, so we have here a plane. Good enough. Okay, so we have a plane and it leaves, it's going between two destinations. It leaves 30 minutes late. Okay. And the distance here is 1,500 miles. Okay. And he has to increase his speed. So its usual speed is X miles per hour. So let X go usual speed in miles per hour. Okay. Um, and so if you're 30 minutes late, then this means you're a half hour late. Okay. Okay, so we have here distance equals rate times time. Therefore, time equals distance over rate. Okay, so it usually takes you, well, let's see. Um, you're usually, well, the distance that you usually travel is 1,500 miles, and you're usually traveling at X miles per hour. Now, you're late, and so you leave a half hour later than normal. Okay, but you want to get there on time, and so you still have to go 1,500 miles, but you have to increase your speed. Oh, so an extra 250 miles per hour. Okay, and so you have to, because you're late, you have to increase your speed by 250 miles per hour. Okay, so that you'll be able to make up that. So let's see, so this is the usual time. So your usual time is, so many hours. Here, your speed time has to be a half hour less. So your usual speed time, the usual time you take is going to be, well, you had a half hour that you left late, plus the time that you're now traveling in the air. And so let me multiply both sides of my equation by um, least common denominator, 2x, x plus 250. And so the x's cancel. And so I have 2 times 1,500, 3,000, times x plus 250 equals, the 2's cancel. So I have x times x plus 250 plus, well, the x plus 250's cancel. So I have 2 times 2x times 1,500 is 3,000 x. Okay, so let me multiply x inside the parentheses. And so I have 3,000x plus 750,000. Wait, yes, because that's 750,000 equals x squared plus 250x plus 3000x. Let me subtract 3000x from both sides of my equation and 750,000 from both sides of my equation. And so I get x squared plus 250x minus 750,000 equals 0. And so let me factor. Bring down the plus times, so bring down the plus times minus gives you minus. I want two whole numbers whose product is 750,000 and whose difference is 250. 1,000 and 750 give you 750,000 and the difference is 250. Set each factor to 0 and solve for x. Subtract 1,000 from both sides. Add 750 to both sides. And so x equals negative 1,000, or x is equal to 750. Airplanes don't usually go 1,000 miles per hour in reverse, and so 750 miles per hour, which is actually quite fast for an airplane that's supersonic. So it's a jet, meaning a military jet. It's actually going quite fast. Let me do problem number 19. If so, hoses A and B together can fill a swimming pool in 6 hours. If hose A, if hose A alone takes 10 hours to fill the pool, how long would it take hose B to fill the pool? Okay, so let's do this. So the fraction of filled per hour by, now I'll say it this way, the fraction of the pool filled by hose A per hour plus the fraction of the pool filled by hose B per hour should equal the fraction of the pool filled by both hose A and B together per hour. Mm, let's see if I can erase. See if I can erase this. Oh, I was able to do it. Okay, good. Okay, so now let's do this. So the fraction of the pool filled by hose A. Well, hose A can fill the whole pool in 10 hours, therefore it can fill 1/10 of it per hour. The fraction of the hose, well, let's do the other side. Fraction of the pool filled by both hoses A and B together. Well, hoses A and B together can fill the tank, the swimming pool, in a total of 6 hours, so they can fill 1/6 of it per hour. Suppose that hose B takes X hours to fill the tank. Then it can fill the pool. Then it can fill 1/6 of it per hour. 1 over X of it per hour. Let me multiply both sides of my equation by 30x. And so I get here 3x plus 30 equals 5x. Subtract 3x from both sides of my equation. And so I have that 30 equals 2x. Divide both sides of my equation by 2. And so x is equal to 15. So the answer is 15 hours. So it takes hose B 15 hours to fill the pool. Okay. Let me do problem number 20. 20. Chanel and Lisa can finish a job in 12 days. If Chanel can finish the same work in 20 days, in how many days can Lisa finish the work? Okay, so we'll do this exactly the same way we did in the other problem. And so Chanel can finish the whole job in 20 days, so she can do 1/20th of it per day. Uh, I don't know how long it'll take Lisa, so I'll say it takes her X days to complete the job, and so she can do 1 over X of it per day. And together, Chanel and Lisa can do it in 12 days, so they can do 1/12th of the job per day. We're, of course, assuming that everything is uniform, that the amount of time that it takes for each of them to complete the job is always the same, uniformly, same rate. And so let me do Let me multiply both sides of my equation by 60x. And so 60x divided by 20 is 3x. 60x divided by x is 60. 60x divided by 12 is 5x. Subtract 3x from both sides of my equation. So 60 equals 2x. Divide by 2. So x is equal to 30. So the answer is it will take her 30 days. Let me do problem number 22. Roosevelt can finish a piece of work in 12 days. And Manuel can finish, can do the same work in 24 days. In how many days? In how many days can the two finish the same work? Okay, so let's do that. And so Roosevelt can finish the job in 12 days, who can do it 1/12 of it per day. Manuel can do it in 24 days, so he can do 1/24 of it per day. And together they can do it in x days, so they can do 1 over x of it per day. Multiply both sides of my equation by 24x. 24x divided by 12 is 2x. 24x divided by x, 24x divided by 24 is x. 24x divided by x is 24. So I get 3x is equal to 24. Divide both sides of my equation by 3. And so x is equal to 8. And so they can complete the job working together in 8 days. Okay, let me do problem number 25. Christy can clean the house in 5 hours, and her father can clean the house in 4 hours. Christy's younger brother, Tom, can completely mess up the house in 10 hours. If Christy and her father clean the house, and if Tom plays in the house all at the same time, how long will it take to clean the house? Okay, so let's see that. So Christy can do it in 5 hours. So she can clean 1/5 of the house per hour. Her father uh, can clean the house in 4 hours, so he can clean 1/4 of the house per hour. And Tom can unclean the house in 10 hours. And so he can unclean 1/10 of it per hour. So we sort of remove the cleanliness. So I subtract from the cleanliness 1/10 of it per hour. And suppose that altogether it takes them X hours to clean the house. So they can do 1 over X of it per hour. And so let me multiply both sides of my equation by the least common denominator, 20x. And so 20x divided by 5 is 4x. 20x divided by 4, 5x. 20x divided by 10, 2x. 20x divided by x, 20. And so I get 7, and 4x plus 5x is 9x minus 2x is 7x equals 20. Divide both sides of my equation by 7. And so I get that x is equal to 20 over 7. And so let's divide. 20 divided by 7, well, that's going to equal 2. I'm sorry. Yeah, 2 and 6/7. Okay. And this is in hours, right? Is in hours. So this is 2 hours plus 6/7 of an hour. Well, there are 60 minutes in an hour. And so there's 60 minutes in 1 hour. And so if I multiply by 60, then I'll convert this from the 6/7 from hours to minutes. So let's do that. So if I multiply, um, I'll get 360. So I get here 2 hours. So that's 360 over 7. 360 over 7 minutes. But if I divide that, I'll get 51. and 3/7 minutes. And so this is 21 hours plus 51 minutes plus 3/7 of a minute. Okay. Well, again, let's rewrite that. There are 60 seconds in 1 minute. And so if I multiply by 60, I'll get 21 hours, 51 minutes, and 180 over 7 seconds. And so this gives me 21 hours, 51 minutes. 180 divided by 7 is 25. Oops. And 5/7 seconds. So this is 21 hours, 51 minutes, and 25 and 5/7 seconds. So this is 21 hours, 51 minutes, 25.71428.5, and then it starts repeating again. And so that's another way of writing it. Okay. Um, and let's see. I think that's it. Yeah, that's it. So that's it.